Hi, it's Mr. Anderson, and welcome back to Chemistry Essentials video number 72 on filtration. Let's start this video off with an example. Let's say we want to mix lead nitrate and sodium iodide together. As the reaction occurs, two products will be formed, sodium nitrate and lead iodide. According to solubility rules, the sodium nitrate will be soluble and therefore liquid, while the lead iodide will form a solid precipitate. The resulting solution will have a liquid substance and a solid substance sitting on the bottom. Let's say you want to isolate the lead iodide from the sodium nitrate. Obviously, you can't just grab it out of the beaker. How can you do this? You'll have to use a process called filtration. Filtration is a separation technique that uses filter paper to separate a solid precipitate from a liquid solution. Now, separation techniques. What are those? Separation techniques are essentially methods used by scientists to separate mixtures into its individual components. Some other methods of this include decanting, distillation, and evaporation, but I'll cover that in a future video. Filtration falls into this category of methods as it is used to separate solid and liquid products of a precipitation reaction. Filtration is based around the concept of particle size. Particle size is separation based upon the size of particles within the solution. Filter paper, the main component of filtration, has very small holes that allow minute substance to pass through while blocking out larger substances. Since liquid particles are much more spaced apart due to weaker intermolecular forces, the particles take up less space and aren't able to pass through the paper. Solid particles, on the other hand, are larger due to stronger intermolecular forces and therefore cannot pass through the openings. As a result, the filter paper separates liquid from solid as it allows liquid to pass while retaining the precipitate. Now that you know what filtration is, you should get acquainted with how to do it. There are four main components to filtration: an Erlenmeyer flask or beaker, a funnel, filter paper, and of course a solution of precipitate. First, you're going to want to fold the filter paper into a cone shape and place it into the funnel. Stick the sides with distilled water to ensure it stays in place. Once the paper is in place, put the funnel with the paper into the beaker. After this, slowly and patiently pour the precipitation solution through the funnel and try to capture as much precipitate as possible. Once all the solution has passed through the filter paper, take the filter paper out of the funnel and unfold it. Allow the paper to dry to ensure any remaining liquid is evaporated, and once it is dry, gather your solid precipitate. In addition to this, there is also vacuum filtration. Similar to gravity filtration, where slowly gravitational pull splits liquid and solid apart, vacuum filtration utilizes suction and pressure to separate the two. Although similar in name, vacuum filtration requires different instruments than gravity filtration. A regular funnel is changed to a Buchner funnel, the flask is changed to a vacuum flask, and rubber tubing is used to connect the flask to create a vacuum within the container. The only two things that stay the same in effect are the filter papers and the precipitate solution. Besides the components, the idea and steps are relatively the same as normal filtration. Add the filter paper, place the funnel in the flask, etc. However, before adding the precipitate solution, connect the rubber tubing from the flask to the outside of a running water source. Connecting the flask to running water will cause a decrease in pressure within the flask. According to the Bernoulli principle, this decrease in pressure will cause the liquid to flow through at a faster rate, separating the liquid and precipitate at a more rapid pace. And so did you learn that filtration is a separation technique that utilizes the differences in particle size between solids and liquids to separate a precipitate from a solution? Remember that filter paper has minute holes that allows for these particles to separate. And did you learn that vacuum filtration is the use of suction and pressure to separate liquid from solid at a faster rate? The decrease in pressure within the flask directly causes the liquid to flow through the paper faster. I hope so, and I hope that was helpful.